Hi, welcome to Grade 6 Math, Module 1, Lesson 1. In this lesson, we're going to talk about ratios and think about ratio is an ordered pair of numbers which are not both zero. You should also understand that we use ratios because when we have two numbers, it's not always true that one is a multiple of the second. So we can use ratios no matter what relationship they have. We will also talk about the language and notation of ratios, like using this colon, which we read as the word two, so we can also write it out as the word two. We will talk about that order is important because the order represents the relationship of two things. So we'll also then talk about real world examples of ratios when they happen. So the first thing about our vocabulary is that the ratio is just the number. We would read this as 2 to 3. But we will have ratio relationships such as 2 centimeters to 3 seconds. So when we have those um, labels, those units on there, then we're talking about the ratio relationship. Sometimes we use that vocabulary interchangeably, but we need to be very careful about what we know and how we use it. Sometimes we will use tape diagrams as we learn about ratios. Tape diagrams might be new to you, so here is an example of a tape diagram. This is not in your module yet. Cameron has 5 shirts and 1 baseball cap. The multiplicative comparison is Cameron has 5 times as many shirts as he has baseball caps. This can be represented with a tape diagram. So here, each of these boxes, you can think of it as a piece of tape. Each of those boxes represents 1 shirt. So here we have 5 boxes, so 5 shirts. And the same size box represents here 1 baseball cap. That's all a tape diagram is boxes. We will use those a lot this unit, so we should start looking to familiarize ourselves with them. But our first example does not have a tape diagram, so let's get to it. Example 1. This is in your module. The co-ed soccer team has 4 times as many boys on it as it has girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. So when we read this, remember that colon we read as the word 2, so that is 4 to 1. What are we going to do with that information? Well, let's start by making a table. If we look at this 4 to 1, if we have 1 girl, that means we have 4 boys. We put this chart in the same order as it was in the question. So boys first and then girls. And how many players total does that give us? That's 5 players. But we can reasonably deduct that there are more than 5 players on a soccer team because that wouldn't really be enough to field a team. So let's continue our chart. That's not big enough for a team. Let's continue. So if we have 1 girl, that means we have 4 boys and 5 players. So let's count up what happens if we have 2 girls. We'll have 4 more boys, which will give us 8 boys, but that's still 10 players. So let's count up. We add 1 more girl. That means we're going to add 4 more boys, which means we'll have 12 boys and 15 players on our team. That's enough to field a team. Could we keep going? Of course, but we don't need to. That ratio of 1 to 4, or boys to girls, 4 to 1, is consistent through this whole table. But suppose that there's another team that has a ratio of 3 boys for every 2 girls. So we could have 3 boys for every 2 girls, which would give us 5 players. What are some other team compositions where there are 3 boys for every 2 girls on the team? So you could continue your table here and say, okay, well, if there are 4 girls, then there would be 6 boys, and that would give us 10 players. Keep on going and you could find out other compositions. But you notice this is not a multiplicative relationship. I can't say, well, there are 3 times as many boys because 3 times 2 is not 3. So we need to look at that ratio to make that multiplicative value. What ratio do we have happening there? Our ratio actually is very closely related to the numbers on our table. Here we have it, 3 over 2 as a fraction. So we have 3/2 as many boys as girls. Or if you prefer decimals for this one, you might be able to see 1.5 boys for every girl. Can't have half a boy, so that's why that 3/2 or 3 to 2 has more reasonable answer. Okay, so can you visualize that? You can't have half a boy, so let's make a tape diagram. So we'll need 3 pieces of tape to represent the 3 boys. And how many pieces of tape for girls? I hope you at least thought 2 pieces of tape for girls. So there are 3 boys, there are 2 girls. It's easier to visualize 3 boys for every 2 girls than it is to think 1.5 boys per girl. Like I said, you can't have half a boy. For example 2, you are supposed to find the ratio of boys to girls in our class. Well, I can't do that for you on the video because every class is different, but you can count the boys and girls in your class and make that ratio. So I'm going to skip that one for the video. And now in your module on the next page, it says to write down some ratios that your teacher gives you. These ratios also talk about the students in your class. How many of you traveled out of state this summer? How many of you did not travel out of state this summer? You make a ratio. How many of you have at least one sibling? You can't do that unless you're in class, so we'll do that together as a class. But right now, we'll move on. Exercise 1 says look around the classroom to find quantities to compare, then create a written ratio statement that represents the ratios in one of the summary forms. So it could be, look around, how many students wearing jeans to the number of students not wearing jeans. It could be, how many students are using pencils, how many students are using pens. It could be, how many students cross their legs, how many students don't. You have a lot of options here, so once again, look around the classroom and make your own ratio. You have to make sure that you put them in the right order because order matters. Imagine we're talking about how many slices of pepperoni are on one slice of pizza. Well, if I say there are 8 slices of pepperoni on one slice of pizza, but I put it backwards, then that means I only get 1 slice of pepperoni on 8 slices of pizza, and that's just not nearly enough. So you have to make sure you put it in the same order that it is in the question. Since we've been talking about boys to girls, we have to make sure we put boys first, the number of boys to the number of girls. So the next thing on your module we need to look at, think of the numbers 1 and 12. What ratio what relationship can you think of that would be appropriate for this ratio. 1 to 12. You can think of lots of things that come in dozens. I think maybe you just did school shopping. One box of pencils has 12 pencils in it. Maybe you got some fruit roll-ups in for your snacks. One box of fruit roll-ups has 12 fruit roll-ups in it. So one box has 12 fruit roll-ups. You can also flip that order. There are 12 pieces of gum in one pack. What else did you buy for school? Or anything you want. You can look around the room. 2 to 5. 5 to 2. Think of your own. 10 to 2. 2 to 10. So you think of some ratios that would come in those numbers. Hopefully you followed along in this lesson fairly easily. Let's just summarize it here together. A ratio is an ordered pair of numbers. It's ordered because order matters, and they can't be zero. It is denoted or written as A colon B to indicate the order of the numbers. A is first and B is second. And that, remember, order is important to the meaning of the ratio. So switching the relationship, switching the order switches the relationship. So that's the magic about ratios. So now check yourself. Can you answer these questions? What is a ratio? Can you describe it in your own words? How do we write them? What are two quantities you would love to have in a ratio of 5 to 2, but hate to have in a ratio of 2 to 5? I'll give you an example of this. I would love to have 5 scoops of ice cream after I only had to eat 2 spoons of asparagus, but I would hate to have 2 scoops of ice cream after eating 5 spoons of asparagus. I don't like asparagus. You can think of food, you can think of money, you can think of a score at a game. Come up with something for yourself if you can do that. So, in your head, can you write a ratio for the following description? Khalil made 3 times as many baskets as John during basketball practice. See if you can answer these questions. If you can, awesome, you're good to go. All right, that's it. I'll talk to you later.